I hope and your family we will first. And before starting, I want to say thank you for this invitation and thank you for trusting me firstly and trusting my project and for this big invitation. So I'm ZITOUNI Lokmane from Algeria. Last year, cybersecurity student in USTHB, University of Science and Technology Houari-Boumediene in Algeria. So I'm AI and security trainer. I'm in IT, core team member, like an AI lead. Also, I'm an IT manager in Google Developer Students Club in my university, USTHB, an artificial intelligence team leader and trainer in Open Minds Club, also in my university. And I'm a full stack JS developer. So I'm here today to present my project. We can see also my innovation in the medical side, medical health, using artificial intelligence under the name of IDM. IDM is an automated diagnosis system of malaria. And I have also many other projects in the field, like this one, like malaria self-diagnosis mobile application, breast cancer self-diagnosis model, and also the brain cancer self-diagnosis model, real-time obstacle detection using YOLO in real time, and other projects. So we're talking now about my presentation, about my short presentation today. We're talking about using an artificial intelligence in medical field. So artificial intelligence refers in the branch of computer science dedicated to creating systems to perform tasks that normally receive human intelligence. So what we use in artificial intelligence in medical field in order to make better and more reliable diagnosis, image recognition for the diagnosis, and cancer retention diagnosis in order to speed up performance and diagnosis times, especially with the large number of the case and the lack of equipment and availability of specialists. So there are some projects I'm talking about it. This is about breast cancer, brain cancer, breast cancer, and today we're talking about this one. It's diagnosis of malaria. And this is some results. So why are we talking about the Plasmodium falciparum malaria parasite detection and prediction system? So because malaria is considered as one of the great deadly diseases, and there are some statistics. In 2019, there were around 229 million cases of malaria worldwide, with an estimated deaths of around 409,000 people, with 67 of them being children under 5. The African region has 94 of global malaria case, according to World Health Organization. This raises major concern and calls for immediate case. So now we're talking about the classical way to detect malaria. Optical microscopy, light microscopy, is one of classical detection method for Plasmodium. Plasmodium is the most virus causing the malaria. It's present a clinical examination allowing microscopists to train in the manually visualization and locate Plasmodium parasite in the blood smear. Does it take a long time, especially with the large number of cases and the lack of equipment and the availability of microscopists? So this is why computer vision is present today, a modern solution and method for diagnosis biomedical image using image processing, machine learning, and deep learning methods. So before starting training models, we need data. We need data who present image for microscopist image for our case. In this case, we need image for malaria. And before starting this, we need to annotate. What is annotation? Annotation is image refers to locate manually the malaria in blood images after that, we can train it. We can train our model. For this case, we're using unit model is the most model used in prediction and segmentation image, also in biomedical field. It's and this is her architecture, two parts, part encoder and part decoder. The first part encoder is training for information extraction, like the color, the form, etc. And the first and the second part decoder, it's here for reveal our image, our output image that contain the location and the segmentation image for that we can start with it in locate and predict our virus. So the process of training is like this. We have data set and we split it into two. We split the data set in two in train case and validation test. So after the train, we say that we annotate it that we can that allow us to have for one image two image. The first one is the original image, and the second image like the output image, because here we're talking about the supervised artificial intelligence. Because there are three types, supervised and unsupervised. But now we're talking about the supervised, that we have an input, we have our input. In this case, we have an image, and there are output. The output is the result. That image have location and the segmentation. And in this point, we can start our training. We chose this model unit, as we say. It's is one of the best model in the field of segmentation. It's useful in medical field. And after all of this, and after the training, we can test and evaluate our model using the validation data set. And for my model, that's it. Results and evaluation. I have 99 as accuracy and 0.002 as loss. It's super model. And this is implementation of my model in application mobile. Why using application mobile? Because application mobile is available around the world. Operate IDM, it's automated diagnosis of malaria. We can choose an image and automated test like this, and this is the result, final image. As and every circle here present a virus of malaria. So yeah, and here we present the diagnosis positive 100%, and this is our final. Starting by image, passing by our segmentation model, and there are our final model and our final image that contain our input image by including the location and position of our malaria. And there are example of infected cell and uninfected. And here we can see the form of our virus, like the special color and special form. Including that, we can training our model. I'm talking about it. It's unit model. This is one. And I guess that's all. So thank you again for this invitation and for trusting my project.